So when you bake or eat bread or muffins, you're appreciating the work of gas and air expanding within the baked goods. So you sample the effects of gas every time you eat a slice of bread or you open a bottle of fizzy water. The process of adding air to food is aeration, and there are a couple of different processes. So mechanical aeration can be demonstrated by a mechanical process such as whisking or beating to create a foam. Now you can use a hand whisk, you could use a hand powered whisk, or you could use an electric whisk. The foam itself is unstable, but it can be made stable by chilling it or by cooking it in such ways as creating a souffle or a roulade. What we've done there is we've mechanically aerated the egg white. We have added small bubbles of air and created extra volume within the mixture, which would be perfect when you bake up your roulade or you're making your souffle.
When you heat up water to boiling point, it produces steam which expands and is used as a raising agent for products such as Yorkshire puddings or profiteroles. The texture steam produces as a raising agent is very open and uneven. Pockets of air are left after the steam has escaped. The gas carbon dioxide can also be added to our food by chemical reactions using an acid and an alkali, or as you might know it, bicarbonate of soda or baking powder and cream of tartar.
So we can demonstrate the acid and alkalis working together with a quick little experiment we like to call volcanic eruptions. We're going to get the flour and we're going to mix in the water and we're going to just create ourselves a real basic little dough on here. Then you're going to place the dough around the yoghurt pot to create a volcanic shape. Once you've done that, we're going to add to your yoghurt pot a little bit of the alkali. We're using the bicarbonate of soda here. About 2 tablespoons. We're going to add a little bit of red food colouring. Then we're going to add our acid, but don't be worried, this is white vinegar, otherwise known as acetic acid. We're going to pour that in and watch our volcano erupt through fizzing or effervescence, which is releasing CO2 in the same way that CO2 would be released into your baked items.
Aeration can also occur through biological reactions such as yeast fermentation. But what exactly is yeast and what does it need to ferment? Yeast is a live, single-cell fungus activated by warm liquid, ideally about body temperature, fed by sugars in flour. Yeast produces CO2 and alcohol.
So yeast are microscopic fermenting machines used for fermenting alcoholic drinks such as beer or lager. And in fact, the froth on top, sometimes called the balm, was used hundreds of years ago to make the bread, although quite a bitter bread. And how microscopic is microscopic? Well, if I was just to get one of my hairs and hold it under this tiny microscope, I would be able to see 15 yeast lined up end to end on the end of one of my hairs. So how many different types of yeast are there? Well, there are over 160 species of yeast out there, and they're all around us, in the air, on our skins, on grain, and on fruit.
In quick breads, which have no yeast, and these breads don't require hours and hours for dough to rise, an instant leavening agent like baking powder or bicarbonate of soda is used, which relies on chemical reactions between the acid and alkali compounds to produce the CO2.
So in baking there are 3 common types of yeast that we use. The first is a fresh yeast, the second is a dry active yeast, both requiring fermentation prior to adding to the ingredients, and the third is a fast action yeast which can be added directly to the dry ingredients. So you might not be able to see the yeast, but you can see the reactions of the yeast. We're going to use some plastic bottles, some yeast and some sugar, but different amounts at different temperatures to see what the reactions will be.
In bottle 1 we have control, yeast, warm water and sugar. In bottle 2 we have yeast, cold water and sugar. In bottle 3 we have yeast, boiling water and sugar. In bottle 4 we have yeast, warm water and no sugar. And in bottle 5 we have yeast, sugar and no water. For this experiment, add 2 teaspoons of dried active yeast to each bottle. Add 1 teaspoon of sugar to every mix that requires sugar. Use 200 ml of water at the required temperature for every mix that requires water. For the mix that requires cold water, use crushed ice.
On a cautionary note, be careful with boiling water. Pour the boiling water into a flask with the yeast first, otherwise you're going to end up with a melted plastic bottle. We'll check back on these in 20 minutes. Okay, so we've come back to our yeast beast experiment and you can see the results here. It demonstrates what conditions are required for the yeast to perform and ferment our food. They need warmth, they need moisture, they need food, and ultimately they need time to produce the carbon dioxide which has inflated this balloon. Take away one of these conditions and you're not going to have full fermentation or a production of carbon dioxide.
So with cold water, it is too cold for the yeast to ferment. With the boiling water, we've killed the yeast. With the yeast, warm water and no sugar, we've not provided any food for the yeast. With the 5th bottle, we've not provided any moisture for the yeast. If one of the conditions that yeast needs to reproduce is unavailable, fermentation does not take place. To demonstrate how chemical aeration can cause foods to rise, we are going to carry out an activity called Luro rockets. What you're going to need for this experiment is the alkali, bicarbonate of soda, some single-ply toilet tissue and some old film canisters.
In addition to some acid. Don't be worried, it's just lemon juice.
Open up the canister and place about 1 centimetre's worth of lemon juice into the bottle. Then cover the top of the canister with a sheet of toilet tissue. This will stop the acid and the alkali from mixing until you're ready for the reaction. Onto that, add between half a teaspoon or a teaspoon of bicarbonate of soda. Finally, add the top and press it down until it clips.
So what I'm going to do now is I'm going to flip the tray over, and once I've done that, the rockets should launch into the air to show you the thrust that can be created through chemical aeration and the combination of acid and alkali.
The acid in the lemon juice and the alkali in the bicarbonate of soda quickly react together to produce carbon dioxide gas. This is the same gas that aerates your food. Gases in our food add variety to our diet. Gas may be added to foods in different ways. For example, mechanically by whisking egg whites, physically by water turning into steam, biologically by fermenting yeast, and chemically by adding baking powder to recipes. Yeast is a living organism which grows best when it has food, warmth, moisture and time to grow. Yeast is available in many different forms. Both yeast and baking powder release the gas carbon dioxide, which makes our food lighter and improves the texture. Baking powder is made from an acid, cream of tartar and an alkali, bicarbonate of soda. When mixed together with a liquid, they produce carbon dioxide gas.